Hello everyone, this is a response video to Good's Feed the Beast series where he asked a very important question, which was whenever going from this high power or high voltage to low voltage, when splitting it up like this, is it better to use batteries or better to not use batteries? And this is the test that effectively answers that. And so right here, this is the battery design, and this is without the battery design. Identical system, except I've removed the batteries. Down here I have the matter fabricator just because it sucks up power. To be honest, that's all I have it for. I'll be using the e-reader to show everything. So first things first, let's hook up to this guy. So this MFSU is hooked up to this quantum generator, which is generating 512. And I'll do the same here. And so what you're going to see here is, I'm sure if you looked at this MFSU, no power. And that's because I'm outputting 512, and if you saw here, outputting 512 again. So this MFSU, even though this guy's outputting power, this guy's outputting power, it's a net change of 0. There's no change. And so then this comes out into these high voltage to low voltage transformers. Okay, it's split up into the 128, and then down here it's still the 128. And whenever we come into these MFEs here, we'll see again 0, the output 128. So we're putting in 128, we're getting out 128. These go into medium to low transformers, and so this here was 32, this here's 32. These go into bat boxes. These bat boxes, sometimes they show 32, sometimes they don't. But again, you see it's not going anywhere. That's because we're putting in 32 and getting out 32. Makes sense. So whenever we connect all these things together, we're getting 512, what we originally put in, which makes sense, actually, and it should, because we're just breaking it up and spitting it out. The difference between the input and the final output is that's one packet of 512, that's 16 packets of 32. You might want that. It really depends on the application. So this over here, we're outputting 512 as well. Sorry, we're outputting 512. Down here, wait, what? Why is this outputting so much power? Oh, I buffed that. Sorry. Yeah, this was from a previous demonstration. I'll show you what that was for. But whenever we output 512, we get 512, and down here it's 512. What you saw there, though, was what was happening whenever I gave it more power than necessary. So this guy here outputs a stupid high amount of power. So we'll feed that in. Now if you notice, we don't get stupid high out over here. That's because we get bottlenecked by these transformers. But these transformers have a maximum input of 512, and so you see here that this line is higher than that line over there. And so down here, we're getting effectively the same. Now if we come over here with the battery system and put in stupid high, first thing we notice, this thing's going to fill up stupid fast. In here we get the stupid high reading, and out here we're only getting 512. That's why this thing's able to charge. And so if we come all the way down here, we're still getting our 512 reading, and that's because the system is storing. Even if all these batteries were completely full, we'd still get the 512 reading. And even whenever this thing fills up, it's not going to disperse power to these MFEs because it's not able to output that much power. See? And so all we've effectively done is just allowed ourselves to store power. Now the other difference, though, is that if we cut the power here, this power that's being generated is effectively lost. It does us no good. We're losing it. It's a waste. This over here, these bat boxes, just to show you, if we cut this power, these bat boxes will start collecting power. These MFEs still do not collect power. That's because they're just in the middle stage. Once these bat boxes fill up, which shouldn't take too long, these MFEs will fill up. Which means if I set this here to charge, and I cut power from the original source, to where now this guy here, because he still has energy, he's still outputting. So we're still getting energy here. If we come over here and break this and connect this over here, we're getting nothing. That is because there's no batteries in the system. And so this is a more stable design. If your input is not constant, if it's flexible like solar panels, you might want this design. But I can do something even better for you. That is to get the output of 2048 and be able to store power. And I'll explain how I'm going to do this. So these batteries are bottlenecking it. Over here, these transformers are bottlenecking it. These transformers are required to go from high voltage to low voltage. And so the only reason why this is bottlenecked here is because this only outputs 512. So if we just make more of these, and I'll show you, we connect the fiber wire to add 4 more of these, and we don't use batteries in the other systems because using batteries down below will bottleneck the system again. We do not want that. Do not want. Okay, so connect that, and connect that. Now if we hook up the 512, that's not going to... 512 here will be sufficient to power everything. Let's go ahead and break this and break this, just so that we don't have any loops here. So this here is going to output the 512, and then this here is going to be a little choppy, just because it's randomly distributing these. And so this down here just gets a random amount of power, but you see how it's roughly 512. This guy here is blinking. Why are you blinking? I don't know why you're blinking. You're just being a pain in the butt, that's all. So we can change this though by putting out stupid high power. Something that's higher than 2048, to where these guys will start filling up. And so now this gets its constant power of 2048, and so we've effectively allowed this now to store power, which is nice, because now if we cut the line here and we come check this, we're still getting our power. And over here, this isn't draining, but I'm sure one of these is just trying to supply the entire system. Or not. Oh, that's what it is. This guy here is done. Let's remove all your energy and start producing some more. Okay, so now these guys are going to start draining. And so we've effectively allowed this higher power system to be able to store energy. And so you want to store the high voltage. And again, these will bottleneck, and so 2048 is the most you're going to get out unless you build more of these. Don't build batteries here because it will bottleneck. And so only store the high voltage. So that's the knowledge I'm leaving with you today, and do with it what you will.